Picture, if you will, the largest hot desert on Earth, stretching across the top of Africa like a vast golden sea. Before we go any further, if you want a brand new Earth topic every single night to fall asleep to, subscribe. One tap and a new story is waiting for you every evening. The Sahara covers more than 9 million square kilometers, an area almost as wide as the entire United States. From the Atlantic shores of Mauritania to the warm waters of the Red Sea, it rolls on and on. Dunes the color of honey, plains of black volcanic stone, wide plateaus of cracked rock that bake under a pale, unflinching sun. To see it from high above is to feel very small. The wind has carved the surface into long parallel waves, like the ripples on a beach. Only each ripple is a dune the size of a small mountain. In places, the sand seems to glow at sunset, soft pink shading into deep amber. In other places, the ground turns nearly white, dusted with salt from old lake beds that dried up long ago. There are mountains here too, dark and silent, rising from the haze like sleeping animals. There are gravel plains so flat and so empty that travelers say they can hear their own heartbeats. And yet, this is the part that quietly astonishes. The Sahara was not always like this. The land beneath your imagined feet was once green. Not just a little green, deeply, lushly green. Rivers ran across it. Lakes filled its low places. Grasses grew waist-high, and herds of animals moved through the soft hills. Hippos wallowed in shallow water. Crocodiles drifted in slow currents. Elephants and giraffes browsed under shady trees. People lived here too, fishing, herding cattle, painting the walls of caves with images of a world that has since vanished. This wetter Sahara is not a myth or a legend. The evidence is in the rock, in the bones, in the layers of old lake mud buried under the dunes. Scientists call those long, wet stretches the African humid periods, or sometimes the Green Sahara. They came and went many times over the last several million years. The most recent one ended only about 5,000 years ago, which, in the long memory of the Earth, is barely a heartbeat. Some of the cave paintings of swimming figures and cattle herds were made by people who saw the green world with their own eyes. here is where the mystery begins to settle gently over the whole region. The Sahara seems to switch back and forth between green and dry, again and again, like a slow heartbeat that beats once every 20,000 years or so. One leading idea ties this pulse to a small wobble in the tilt of the earth, which changes how much summer sunlight falls on North Africa, and which can pull the reins of the monsoon farther north or push them back south. When the rains reach deep into the desert, the land wakes up. When they retreat, the sand returns. That is one theory, and it is supported by a great deal of careful work in ocean sediments and lake cores. But the picture is not as tidy as it sounds. Some researchers wonder whether the flip from green to dry happened slowly, over thousands of years, or whether it happened suddenly, in only a few centuries, as if a switch were thrown. The cores tell different stories in different places. Other researchers ask whether early human herders, with their cattle and their fires, may have helped tip a fragile landscape from grassland into dust. The evidence is incomplete. The argument is gentle and ongoing. So we are left with a very large and very quiet question to carry into this long night. What ancient world lies buried beneath the Sahara, sleeping under the dunes? And when exactly will the desert turn green again? Because if the pulse continues, it will. Sometime, the next slow wobble of the earth will bring the rains creeping back. Whether that happens in 1,000 years or 10,000, or whether our changing climate will speed it up, slow it down, or break the pattern altogether, no one yet knows. For now, the Sahara lies still in the moonlight. Its dunes shift by inches. Its dry riverbeds wait. Its stones hold the imprints of fish and ferns and footprints. Beneath the sand are old lake beds, old shorelines, old paths walked by people whose names we will never learn. We will spend the next many hours wandering through those layers, gently, in no particular hurry. There is so much down there, and so much we do not yet understand. Beneath the still surface of the Sahara, hidden under all that sand and stone, there are rivers, not the kind that move and shine in the sun. These rivers are old, they are quiet, they are buried, and to understand them, it helps to first understand the desert that covers them. in the simplest terms. The Sahara is the largest hot desert on Earth. It stretches across the top of Africa from the Atlantic Ocean in the west to the Red Sea in the east. That is a span of about 3,000 miles. If you placed it over the United States, it would reach from the coast of California all the way to the coast of Virginia, with room to spare. From north to south, it covers roughly 1,000 miles, brushing against the Mediterranean at the top and fading into the dry grasslands of the Sahel at the bottom. Altogether, it covers about 3.5 million square miles. That is nearly the size of the entire United States, packed into one slow, glowing sheet of sand and rock. Most people picture the Sahara as endless dunes. The truth is gentler and stranger. Only about a quarter of the desert is sand. The rest is gravel plain, bare stone, dry mountain, and cracked salt flat. There are plateaus that rise like tables into the dry sky. There are dark volcanic peaks in the central highlands. There are valleys so wide and flat that the horizon seems to bend away from the eye. The sand seas, the great dune fields, sit in pockets across this vast floor like sleeping oceans of gold. Now picture all of that, and then picture what lies underneath. Far below the surface, hidden under hundreds of feet of dry rock and packed sediment, there are old riverbeds. Some are small, some are enormous. Satellite radar, which can see a short distance into dry sand, has traced the ghostly shapes of channels that once carried water across the desert. In places, these buried rivers were as wide as the Nile. Some may have been wider. They wound and forked and joined, the way living rivers do, before they fell silent and the dunes drifted over them. These were not small streams. Researchers studying the radar images believe that one ancient river system in what is now Western Sahara may have run for hundreds of miles, draining highlands that no longer hold water. Another buried network traced under eastern Libya and Egypt seems to have linked the central highlands to the Mediterranean coast. The exact ages of these channels are not fully settled. Some likely flowed during the most recent Green Sahara, only a few thousand years ago. Others may be far older, carved during wet periods that came, and went across hundreds of thousands of years. There is also water down there. Not flowing water for the most part, but stored water. Deep beneath the desert sit some of the largest groundwater reserves on the planet. One of them, called the Nubian Sandstone Aquifer System, lies under parts of Egypt, Libya, Sudan, and Chad. It holds an estimated 150,000 cubic kilometers of water. That number is hard to feel, so try this. It is roughly the volume of Lake Michigan, multiplied many times over, locked into the pores of stone deep below the dunes. Much of that water seeped down during the wet green phases, when rains soaked into the ground and slowly worked their way into the rock. How old is this water? Studies of the deepest layers suggest some of it fell as rain tens of thousands of years ago, when the desert was still a land of lakes and grass. In a few places, the water may be even older, dating back perhaps 1,000,000 years. It sits in stone, undisturbed, while the dry winds move above. The simplest way to picture it all is this. Imagine a great sheet of stone and sand laid across the top of a continent. On top, heat, silence, and slow-moving dunes. Just beneath, the dry tracks of vanished rivers etched into the rock. Deeper still, vast, quiet bodies of ancient water, held in place by layers of sandstone, waiting in the dark. How much of this hidden geography we have truly mapped is still an open question. The radar can only see so far. The deep aquifers are charted in broad strokes, but their fine shape is mostly guessed at. Some researchers think the Sahara may hide whole, branching networks we have not yet found. For now, the desert keeps most of its underground story to itself, and we sit above it, wondering what runs beneath our feet. In the western reaches of Mauritania, far from any city, there is a strange shape pressed into the desert floor. From the ground, you would barely notice it. The land looks flat and dry and tired, the way so much of the Sahara looks. But from high above, from the window of a passing aircraft or the lens of a satellite, the shape reveals itself. A great circle of stone, rings within rings, like the ripples a stone makes when it falls into still water. It is nearly 30 miles across. People call it the Eye of the Sahara, or sometimes the Richat structure. And for a long time, no one could agree on how it came to be. When the first astronauts saw it from orbit in the 1960s, they were puzzled. The shape was so round, so neat, so deliberate. It looked, at first glance, like the scar of something that had fallen from the sky. An asteroid, perhaps, slamming into the ancient Earth and leaving a perfect bullseye behind. That was the early theory, and you can understand why. The rings are clear. The center is bright. The whole thing has the quiet symmetry of an impact crater. But the more geologists studied the eye, the less the impact theory held together. A meteor strike leaves certain fingerprints in the rock. It shocks the minerals. It melts and warps them. It scatters strange glass and tiny crystals shaped by sudden heat. The eye, when examined closely, did not carry those fingerprints. The rocks were old, but they were not shocked. They were not the kind of stone you find at the bottom of a crater. Whatever made this circle, it was not a falling sky. So the question shifted. If not an impact, then what? Today, the most widely accepted explanation is a slow and patient one. Around 100 million years ago, deep underground, a great dome of molten rock pushed upward. It lifted the layers above it like a hand pressing up from beneath a blanket. The blanket did not tear. It simply rose into a gentle bulge. Inside that bulge, hot fluids moved through cracks and chambers, hardening certain layers and softening others. Then, over tens of millions of years, the dome cooled, the pressure faded, and the wind and rain of an older, wetter Sahara began to wear the surface away. The softer rings eroded faster. The harder rings stood their ground. Slowly, layer by layer, the dome was undressed from the top down, revealing the concentric rings of stone that lay inside it. What we see today is not the dome itself. It is the cross-section of a dome, sliced open by time. The eye is not a wound. It is a fingerprint left by deep heat, pressed into the crust, and then unwrapped by patient erosion. That, at least, is the leading idea. Other researchers have wondered if something stranger happened down there. Some have suggested that a rare kind of underground collapse helped shape the rings. A sinking and shifting of layers as the dome cooled and fluids drained away. Others have looked at the unusual mix of minerals at the center and the curious flatness of the surrounding land, and asked whether the eye might be the worn remains of an old volcanic system that never quite broke the surface. The competing theories are not wild. They are quiet adjustments, small disagreements about which forces did the most work and in what order. The full recipe is still being argued. What everyone agrees on is the timescale. The eye is old, older than mammals walking on land in their modern forms, older than the Sahara itself. The oldest rocks at the center may be more than 2 billion years old, lifted from the deep basement of the continent and exposed by the long undoing of the dome above. When you stand in the middle of it now, surrounded by pale stone and quiet wind, you are standing on layers that formed before any animal had eyes to see them. And there is one more soft mystery worth holding. A few researchers have wondered whether the eye, in some ancient era, might have held a lake at its center, a green hollow in a green Sahara, ringed by walls of stone. The idea is speculative. The evidence is thin, but the shape of the place invites the imagination. A perfect circle of rings in a desert that was once wet, in a land where so much has been buried and forgotten. We may understand the eye more completely one day. For now, it stares up from the stones, holding its long, slow secret beneath the sun. Tonight we wonder about cities, not the bright cities of today, but older ones. Places where people once gathered, traded, built walls, drew water from wells, and then somehow slipped from memory. The Sahara is a quiet keeper of such places. Beneath its dunes, beneath its gravel plains, beneath its salt flats and its red rock, the desert may still hold the bones of towns we have never named. To understand how a city can vanish here, it helps to think about what the desert is made of. The Sahara is not one thing. It is a vast patchwork of sand seas, stony plateaus, dry riverbeds, and salt pans. The sand itself is mostly quartz, tiny rounded grains worn down over countless years by wind and water. Quartz is silicon and oxygen, the same building blocks that make glass. Each grain is, in a quiet way, a piece of an older mountain, ground down across deep time. Mixed into the sand are darker minerals. Tiny flecks of iron oxide give some dunes their warm orange and red color. That iron, like the iron in every desert rock, was forged long ago in the cores of dying stars. When those stars collapsed and scattered their elements, the dust drifted through space, gathered into our young planet, and settled into its crust. The same iron that paints a Saharan dune at sunset also runs in the blood of every animal that crosses it. Beneath the sand, the bedrock tells deeper stories. There are sandstones laid down by ancient rivers. There are limestones built from the shells of sea creatures, back when shallow oceans covered this part of Africa. There are layers of salt and gypsum from lakes that slowly dried under a hotter sun. The desert floor is, in places, a stacked library of vanished worlds. Among these layers, people once lived. We know they did because their stone tools, their pottery shards, their fire pits, and their painted walls keep turning up. Some of these sites date back many thousands of years to a time when the Sahara was green. There were rivers, lakes, herds of cattle, and small settlements scattered across what is now empty sand. When the rains pulled away and the green faded, the people moved with the water. The places they left behind were slowly buried. There are old stories, too. Travelers across North Africa have long whispered about a lost oasis called Zerzura. In the tales, Zerzura is a white city in the deep desert, ringed by palms, watched over by sleeping kings, hidden somewhere beyond the known caravan routes. European explorers in the early 20th century spent years searching for it. They flew small planes over the dunes, mapped uncharted valleys, and followed local guides into the dry hills. None of them found a white city. Some researchers believe Zerzura was always a legend, a poem the desert dreamed about itself. Others wonder if the story is a folk memory of a real place, a true oasis that flourished during a wetter period and was then slowly covered by drifting sand. There is no agreement. The evidence is thin. The story remains open. What we do know is that real towns have been lost here, even ones we can name. Garama, the old capital of the Garamantes sat in what is now southern Libya, surrounded by a clever system of underground water channels. The people there grew wheat and grapes in the desert by drawing on fossil groundwater laid down during wetter ages. When the water ran low and the climate shifted, the town shrank. Sand and time did the rest. There may be others. Satellite images sometimes reveal faint shapes beneath thin sand, patterns that look like walls or field boundaries. Archaeologists carefully dig and sometimes find old hearths, broken pots, the curve of a buried foundation. Sometimes they find nothing. The desert holds its secrets unevenly. The materials of these lost places are humble. Mud brick made from clay and straw and river silt, stone gathered from nearby hills, pottery shaped from local earth and baked in simple kilns, beads of carnelian and ostrich shell, iron tools smelted from ore that traces back, like all iron, to those long dead stars. When wind moves across the dunes tonight, it is moving across this hidden record. Some grains of sand are older than any city. Some may have once been the wall of a house, ground down so finely that no one could ever tell. How many towns lie sleeping out there beneath how many meters of sand? We honestly do not know. The desert keeps its count to itself, and for now, we only wonder. Deep in the southeast corner of Libya, in a region of bare rock and silent wind, there is a cave painted with figures who appear to be swimming. Their arms reach forward. Their legs trail behind. They float across the stone with the soft, easy motion of bodies in water. The cave is called the Cave of Swimmers, and it sits in a place where no water has flowed for thousands of years. The nearest pond is hundreds of miles away. The paintings are small. Some are no bigger than your hand. They were made with simple pigments, ground from the rocks themselves, mixed with fat or water or saliva. The artists pressed their fingers and brushes to the stone and left behind tiny red and brown shapes that have outlasted empires. The cave around them is dry now. The sand at the entrance is fine and pale. The wind that creeps inside carries no moisture at all. To understand how this place came to be, we have to think about the slow forces that shape a desert. The Sahara is not still. It only seems still. Beneath the surface of every dune and every flat stretch of gravel, enormous, patient forces are at work. The sun heats the ground each day to temperatures that would scald skin. At night, the heat escapes upward into a clear sky, and the rocks cool so quickly that they sometimes crack with a soft popping sound. Over thousands of years, this daily swelling and shrinking turns boulders into pebbles and pebbles into sand. The wind is another sculptor. It blows in long, steady currents across the open ground, and it carries the dust of broken stones. Where it meets a cliff, it scours. Where it slows, it drops its load. Caves like the Cave of Swimmers were carved out by countless centuries of this slow grinding. The wind worked the soft rock the way a patient hand works clay. It opened hollows. It smoothed walls. It left flat surfaces that one day became canvases. But wind alone does not explain the swimmers. For people to paint swimmers, there had to be swimming. And for there to be swimming, there had to be water. This is where the forces shift from stone to sky. The Sahara's climate is shaped by something called the monsoon belt, a wide ring of moist air that drifts across the planet near the equator. The position of this belt is not fixed. It wanders slowly north and south over thousands of years, pulled by tiny wobbles in the way the Earth tilts on its axis. When the tilt is just right, the monsoon belt drifts north. Rain falls on what is now the Sahara. Lakes appear, rivers run, grasses spread across the sand. When the tilt shifts back, the belt retreats, and the rain stops, and the desert returns. This slow swing is called orbital forcing, and it is one of the great invisible forces shaping the face of our planet. It is gentle. It is patient. It takes tens of thousands of years to complete a single cycle. Some researchers believe the Cave of Swimmers was painted during one of these wet periods, perhaps 8 or 10,000 years ago, when the region held shallow lakes and reed-filled shores. The figures may show real people swimming in real water in a place we can no longer recognize. Others wonder if the swimmers are something else entirely. Perhaps they are spirits or ancestors ancestors, or souls moving through some other element. The painters did not leave us a key. They left us only the figures and the silence of the cave. What pushes and pulls a desert into being is not only the wind and the sun. It is the slow tilt of the earth itself. It is the path of the sea breezes far to the south. It is the heat held in the dark blue waters of the Atlantic. It is the great rising columns of warm air above the equator, which sink again over the Sahara and press the moisture out of the sky. These forces work together, and sometimes against each other, like the slow gears of a vast and quiet machine. The swimmers float on their stone wall, untouched by any of this. They do not know that the lake outside has vanished. They do not know how many years have passed. They keep their arms outstretched, their legs trailing, frozen in a moment of grace from a world that has slipped away. The forces that erased that world are still at work. One day they may bring it back. One day the swimmers may once again look out on water. The question of when and whether remains open. In the western desert of Egypt, far from any coastline, there is a quiet valley made of pale stone and golden sand. The wind moves softly here. The dunes shift in slow ripples, and lying on the ground, half buried in the warm grit, are the bones of whales. Not small bones, not fragments, whole skeletons, some of them longer than a city bus, resting in a place where no ocean has touched the earth in tens of millions of years. The valley is called Wadi al-Hitan, which means the Valley of Whales. It sits roughly 150 kilometers southwest of Cairo, in a sea of dry hills. To stand among these bones is to stand at the bottom of a vanished ocean. 40 million years ago, this place was warm, shallow water. The Tethys Sea, an ancient ocean that once stretched across what is now North Africa and the Middle East, washed gently over what would become the heart of the Sahara. Try to picture the scale of that lost sea. If you placed a modern blue whale beside one of these fossils, you would see something strange. Many of the Wadi al-Hitan whales were smaller than today's giants, but their bodies still stretched 15 to 18 meters long, about the length of a school bus laid end to end. And they still had tiny hind legs, real legs knees and toes, dangling uselessly from creatures that had only recently left the land. These were whales caught in the middle of becoming whales. The scale of time here is hard to feel in the body. 40 million years. If you counted 1 second for every year that has passed since these animals swam over this spot, you would still be counting 1¼ years from now, day and night, without rest. The pyramids of Giza, only about 4,500 years old, are practically newborn compared to these bones. The whole story of human civilization, from the first cities to this very moment, would fit into the final blink of that long count. The Sahara itself, in its current dry form, is only a few thousand years old in some places. Yet beneath its surface, the rock holds memory upon memory, layers of seabed, layers of riverbed, layers of forest floor, layers of grassland. The desert we see today is the thinnest skin over a deep stack of vanished worlds. Consider how far the ancient coastline reached. The Tethys Sea covered an area roughly the size of the modern Mediterranean, and then some, swallowing parts of what are now Libya, Egypt, Algeria, and Tunisia. Where camels now walk, sharks once cruised. Where the dunes now sing in dry wind, sea turtles once paddled through warm currents. Mangrove forests likely lined the shallow edges. Sea cows grazed on underwater meadows. The fossils at Wadi al-Hitan include not only whales, but also the bones of these other ocean creatures, all resting together in the same dry valley. The size of the Sahara today only deepens the wonder. The desert covers about 9 million square kilometers, nearly the size of the entire United States. If you walked across it at a steady pace, never stopping, it would take you well over a year to cross from the Atlantic coast to the Red Sea. And under every step of that walk, somewhere in the deep rock, there are likely fossils, bones, shells, teeth, footprints in stone. Only a tiny fraction has ever been studied. What we do not know is how much remains hidden. One estimate suggests that fewer than 5% of the Sahara's fossil-bearing layers have been carefully mapped. Some researchers think entire species, entire ecosystems, are still resting under the sand, never named, never seen. Others wonder if the shifting dunes themselves are slowly grinding away fossils we will never recover, the desert may be preserving and erasing at the same time. In a balance no one has fully measured. There is also a quieter mystery. Why are the whales of Wadi al-Hittan so well preserved, while in many other ancient seabeds the bones have crumbled to dust? One idea points to the fine, soft mud that buried them quickly after death. Another suggests the dry climate that arrived later locked everything in place, holding the bones in a kind of slow stone embrace. The full answer is still being pieced together. For tonight, let the scale settle around you. A desert larger than a continent, an ocean older than the moon's familiar face in our skies, whales with little legs sleeping in the sand, and under your imagined feet, layer upon layer of worlds that came before, waiting in the quiet dark beneath the dunes. Imagine you could rise above the desert at dawn, just a few hundred feet up, and let the wind carry you slowly across the surface. Below you, the sand glows soft pink in the first light. The shadows are long and blue. The dunes stretch out in every direction, curve after curve after curve, like the slow swell of a frozen ocean. From this height, the Sahara looks calm, almost still, but the dunes are not still at all. They are walking. The largest dunes in the Sahara can rise more than 500 feet from base to crest. Some climb even higher. They are taller than office towers, broader than small towns, and they move, not in any way you could see by watching for a minute or an hour. Their motion is patient. A typical dune may shift only a few yards in a year, but over a human lifetime, that adds up. Over 1,000 years, a dune can travel miles. The wind does the work, one grain at a time. A breeze lifts a single grain of sand from the gentle slope on the windward side. The grain hops, lands, knocks 2 more grains loose, and those grains hop too. This soft, hissing dance is called saltation, which is just the slow leapfrog of sand across a surface. Grain by grain, the windward slope is shaved away. Grain by grain, the sand is carried up and over the crest. Then it tumbles down the steeper face on the other side, the slip face, and settles. The whole dune has moved forward by the width of a few grains. The wind never stops. Neither does the dune. If you floated lower, close enough to see the texture, you would notice that the surface is not smooth. It is rippled like the ribs of a sleeping animal. These small ripples form within hours and reshape themselves through the day. Each ripple is its own miniature dune, made of the same patient hopping. The desert has dunes inside dunes inside dunes, a pattern that repeats across many scales. The colors shift with the hour. At sunrise, the sand is pale rose. By mid-morning, it warms to honey and pale gold. At noon, when the sun is highest, the dunes turn almost white, washed out by the brightness, and the shadows shrink to thin lines beneath the crests. In the late afternoon, the gold deepens to amber, then to copper. As the sun sets, the slip faces burn orange, while the windward slopes fall into cool, violet shade. At night, under a clear sky, the dunes turn silver, and the ripples cast tiny moon shadows of their own. Not all dunes look the same. Some are long ridges that run for miles, parallel to the wind, like the wake of a ship. Some are crescent-shaped, with two trailing horns pointing downwind. Some are tall stars with 3 or 4 arms, formed where winds blow from many directions through the year. These star dunes barely travel at all. They stay rooted, growing taller in place, while the simpler crescents wander steadily across the plains. The Sahara holds all of these shapes, sometimes within sight of one another, a museum of what wind can sculpt from loose grains. The mystery here is quiet, but real. Researchers can describe how a single dune moves, and they can map how whole dune fields shift over decades using satellites. But predicting exactly where the sand will be a century from now is harder than it sounds. Dunes interact. They merge. They split. They sometimes seem to pass through one another, the front of one dune feeding the back of the next. Some scientists think dune fields behave a little like flocks of birds, with each dune nudged by its neighbors. Others see them more like slow fluids, governed by simple rules at the grain scale that build into complex shapes over centuries. The debate is open. There is another open question hidden in the marching dunes. The Sahara as a whole is slowly creeping south in some regions and slowly retreating in others. The southern edge, where the desert meets the dry grasslands of the Sahel, shifts back and forth with the rains. Whether the dunes will keep advancing or quietly fall back is not settled. The same wind that built them may, in time, unbuild them. For now, the dunes walk on. They cross dry riverbeds. They bury old wells. They part around hard ridges of rock and rejoin on the other side. Above them, the stars wheel. Below them, the deeper Sahara waits, half remembered, half hidden. And the sand moves, grain by patient grain, while the desert breathes its long, slow breath. There is a strange thread that ties two distant places together. One is the driest desert on earth. The other is the wettest forest. Between them stretches an entire ocean. And yet, somehow, the desert feeds the forest. The sand of the Sahara, carried high into the sky, drifts west across the Atlantic and falls softly onto the green canopy of the Amazon. It sounds like a quiet kind of magic, but it is real, and it happens every year. Each spring, strong winds lift fine dust from a low basin in the central Sahara. The dust climbs thousands of feet into the air. Some grains are smaller than the width of a human hair. They ride the trade winds for days, drifting across the sea in long pale plumes that satellites can see from far above. When the dust finally falls, it lands on leaves, on rivers, on the dark soil of the rainforest floor. And inside each grain is something the Amazon badly needs. The grains carry phosphorus, a kind of mineral that helps plants grow. The Amazon soil, washed by constant rain, loses phosphorus quickly. Without a fresh supply, the great forest would slowly starve. So the desert, in its quiet way, keeps the forest alive. The basin where most of this dust begins is called the Bidele. It sits in the country of Chad, in a low spot between high lands. Long ago, this place was the bottom of a giant lake. Some researchers think that lake was once as large as a small sea. When the climate dried out, the water vanished. What remained was a soft white floor of dead microscopic creatures called diatoms. Their tiny shells crumbled into fine powder. That powder is what the wind lifts today. So the dust that feeds the Amazon was once the body of a lake. the forest is being fed in part by the ghost of an ancient sea. It is a slow exchange, written across thousands of years, and it raises a soft question that scientists are still trying to answer. How much of the Amazon truly depends on this dust? Some studies suggest that without the Sahara, the rainforest would weaken. Others argue the forest could survive on its own, using nutrients already locked in its roots and rivers. The full picture is still being measured. The numbers themselves are hard to hold in the mind. Each year, the wind carries somewhere around 180 million tons of dust off the African coast. About 1/10 of that reaches South America. The rest falls into the sea, where it feeds tiny ocean plants called plankton. Those plankton make oxygen and pull carbon from the air. So the dust does not only feed a forest, it also feeds the ocean, and through the ocean, the breath of the planet. The path of the dust is not always the same. In some years, the plume is wide and thick. In other years, it is thin and faint. The reasons are still being studied. One idea is that small changes in rainfall over West Africa shift the winds. Another idea is that the Bidele itself changes, depending on how dry the surrounding land becomes. There may be longer rhythms too, tied to ocean temperatures far away. The truth is likely a blend of many things working at once. What feels most striking is the depth of time hidden in this exchange. The lake that left the dust dried out thousands of years ago during the slow ending of the last green Sahara. The diatoms that became the dust lived even earlier, when the basin was full of clear water and waving reeds. Their lives were short and small. Yet their remains now travel halfway around the world, feeding forests they could never have imagined. It also hints at something we still do not fully understand about the Sahara itself. The desert is not a closed place. It is not just an empty stretch of sand. It is a slow engine breathing dust into the sky, sending pieces of its old lakes and old rivers to lands far away. What else might it be sending that we have not yet measured? What other minerals, what other ancient remains drift in the high air above us, unseen? The thought is a gentle one to rest with. Somewhere over the dark ocean tonight, thin veil of pale dust is moving slowly west. It carries the memory of a vanished lake. It will fall in time onto green leaves a world away, and the forest will drink it in and grow a little, and never know the name of the desert that fed it. The connection is quiet. The connection is old, and much of it remains, for now, a question. Long before the Sahara wore its present face of sand and stone, people walked across it. They walked through grass that rose to their knees. They walked beside lakes wide enough to hold the reflection of whole hills. They moved in small bands, following animals, following water, following the slow pulse of a desert that was not yet a desert. And the question that lingers, even now, is when those first crossings began, and how often they happened, and what shape they truly took. The Sahara does not stay one thing for long. Over the past few 100,000 years, it has shifted between green and gold many times, like a great slow heart. Scientists call these wet stretches the African humid periods. During them, the rains came farther north, the rivers ran full, and the grasses spread. Then, slowly, the rains pulled south again, and the sand returned. This rhythm seems to follow a long wobble in Earth's orbit, a gentle tilt that takes roughly 21,000 years to complete its turn. Each green pulse opened a door. Each dry pulse closed it. And in between, people moved. One theory holds that the earliest modern humans used these green windows to leave the heart of Africa and reach the lands beyond. When the Sahara bloomed, it became a corridor rather than a wall. Rivers led north toward the Mediterranean. Lakes appeared where dust storms now blow. A traveler could walk for weeks through wet grasslands without ever running out of water. Some researchers believe that the great spread of our species across the world rode on the back of these wet phases. Stepping out of Africa, each time the desert turned soft. Another view places the crossings along the edges instead. In this picture, people moved mostly along the Nile Valley or along the coasts, hugging the water rather than risking the open interior. The Sahara, even in its green form, was not a paradise. It still had dry seasons, harsh winds, and long stretches between safe camps. perhaps only small groups dared the inner crossings, while the larger movements followed the rivers and the sea. The truth is, we do not yet know which picture is closer to what happened. Both leave traces. Both leave gaps. What we do find, scattered across the modern desert, are quiet hints. Old stone tools rest beside dry lake beds, sometimes hundreds of miles from any living water. Fish hooks carved from bone have been pulled from sand that has not felt rain in centuries. Grinding stones lie where no grain could grow today. Each one is a small whisper from a wetter time, left behind by people whose names we will never learn. The cave paintings of the Tassili Enager add their own layer to the puzzle. On the walls of those high rock shelters, ancient artists painted herds of cattle, hunters with bows, swimmers, dancers. Some of the figures are thought to be more than 8,000 years old. They show a world full of life in a place that is now almost empty. But the paintings do not tell us where the people came from or where they went when the rains failed. They only show that for a long stretch of time, the desert was home. There are deeper questions still. How quickly did the Sahara green, and how quickly did it dry? Some studies of lake sediments suggest the changes came in centuries, slow enough for generations to adapt. Other studies suggest the shifts could be far sharper, with whole regions turning to sand within a single human lifetime. If the faster picture is right, then the people of the Green Sahara would have watched their lakes shrink before their eyes, their grasslands fade, their familiar paths grow strange. They would have had to choose again and again whether to follow the water or stay near the bones of the old places. The cycles continue. The orbital wobble that drove the past Green Saharas has not stopped. In tens of thousands of years, the rains may drift north once more, and the dunes may soften again into grass. Whether human hands will be there to see it, and what kind of crossings the new Green Sahara might invite, are questions far beyond our reach. For now, we are left with the silence between the pulses. We know the desert breathes. We know people moved through its wet breaths and clung to its edges during the dry ones. But the names of the first crossers, the routes they chose, the songs they sang as they walked, all of these lie buried beneath the sand. The Sahara remembers them in fragments. We piece the fragments together slowly, and we wonder. For all its emptiness, the Sahara has never truly been alone. Around its edges and across its middle, other worlds have always pressed in. Green coasts to the north, the wide grasslands of the Sahel to the south, the Nile Valley to the east with its long ribbon of life, and to the west, the slow, cold breath of the Atlantic. The desert sits between these neighbors like a vast, quiet room. And for thousands of years, people have crossed that room carrying something precious. Salt. It is strange to think of salt as treasure. Today, we sprinkle it from a shaker and forget it. But for much of human history, salt was as valuable as gold. People needed it to live. They needed it to keep meat through long seasons. They needed it for their animals. And in the heart of the Sahara, in places like Tagheza and Taoudeni, there are old beds where salt lies in thick white slabs, buried in the sand like the bones of a forgotten sea. People dug it out by hand. They cut it into heavy blocks, and then they tied those blocks to the sides of camels and walked. The caravan routes stretched for thousands of miles. They linked the salt mines of the deep desert to the markets of the south, where gold waited in the hands of kingdoms like Ghana and Mali and Songhai. Salt moved south, gold moved north, and the camels, swaying in long brown lines, carried both across the dunes. A single caravan could hold 1,000 camels, sometimes more. From the air, if anyone could have seen them, they would have looked like dark threads stitched across the pale cloth of the desert. How did these caravans find their way? That is one of the quieter mysteries of the Sahara. There were no roads. The dunes shift. Landmarks vanish. Sandstorms can erase a trail in an afternoon. Yet the guides, often men from desert tribes like the Tuareg, walked these routes with a confidence that still puzzles those who study them. Some say they read the stars. Some say they knew the shape of the wind, the taste of the air, the feel of the sand under their feet. Some say the knowledge passed from father to son in songs, each verse a piece of the map. The truth is probably a weave of all these things, and much of it has been lost. There are stories, too, of places along the routes that no one can find anymore. Wells wells that gave sweet water for a single season, then dried. Small green hollows tucked between cliffs, known only to a few. The legends speak of a lost oasis called Zerzura, a white city full of birds and gardens, hidden somewhere in the western desert. Explorers searched for it for centuries. Some claimed to have glimpsed it. Others called it a dream made by thirsty men. Whether Zerzura was real or a memory of an older, greener time, or simply a longing given a name, no one can say. What we do know is that the desert held more life than it shows now. The caravans did not invent these routes. They followed older paths that may have been walked when the Sahara was still partly green, when there were rivers and lakes, and small bands of herders moving with their cattle. The salt roads, in a sense, are the ghosts of older roads. Layer upon layer of footsteps, pressed into the same sand by different feet across thousands of years. The neighbors of the Sahara shaped what the caravans carried. From the forests of West Africa came kola nuts and ivory. From the north came cloth and books and glass. From the east came spices and ideas. The desert was a great slow market, and the camels were its quiet trucks. Whole cities grew on the edges of this trade. Timbuktu became famous for its libraries. Sijil Massa, on the northern edge, swelled with merchants. When the routes shifted, when ships began carrying goods around the coast instead, those cities faded. Some were swallowed by the sand they had once defied. Walking through that history now, you find broken pots and old coins, the bones of camels in places where wells used to be, the faint dark lines of trails that the wind has nearly smoothed away. The neighbors of the Sahara are still there. The Sahel still hums with herders. The Nile still flows. The Atlantic still breathes against the western dunes. But the long brown threads of the caravans have grown thin. And what they truly knew about crossing that vast, quiet room may already be passing out of memory into the same silence that holds everything else the desert has taken in. Far out in the southern Sahara, where the dunes finally give way to harder ground, there are stones arranged in shapes that should not be there. They sit in circles. They sit in long lines. They sit in clusters that seem to follow some forgotten pattern. The desert wind passes through them. The sun rises and sets behind them. And no one alive today can say with certainty who placed them or why. The most famous of these stone fields lies in a place called Nabta Playa, in the deep south of Egypt. Long ago, this dry basin was a shallow lake that filled with rainwater during the green Sahara. Around its old shoreline, people set heavy stones upright in the ground. They dragged them from far away. They aligned them with care. And then, slowly, the lake dried up, the people left, and the stones stayed behind. Some of these stones are taller than a person. Others are low and flat, half buried in the dust. They form a rough circle with smaller stones inside it and longer rows that stretch outward across the open ground. The arrangement is old, very old. Some studies suggest the site is around 7,000 years old, which would make it older than the great stone circles of northern Europe. The question of what the circle was for has no settled answer. One theory points to the sky. Researchers who have mapped the stones believe some of them line up with the position of the sun at the summer solstice, the longest day of the year, in a land that depended on the seasonal rains. Knowing when the sun reached its highest point would have mattered. A stone calendar set into the earth may have helped these early herders predict the coming of the water. Another theory looks beyond the sun and toward the stars. Some scholars have suggested that certain stones may line up with bright stars in the constellation we now call Orion, as they appeared in the sky thousands of years ago. If true, the circle would be one of the oldest known places where humans tried to mark the patterns of the night. Other researchers are more careful. They point out that with enough stones and enough stars, alignments can appear by chance. The evidence, they say, is suggestive, but not yet firm. There are also stranger stones at Nabta Playa, buried below the surface. Beneath the open ground, archaeologists have found large-shaped slabs lying flat, set deep into the earth. Some of these slabs sit above pits that contain the bones of cattle. Cattle were sacred to the people who lived here, and the careful burials suggest a ceremony, a belief, a meaning we can only guess at. Was this a place of worship, a burial ground for animals that fed the community, a monument to the rains. The stones do not say. The Sahara holds other stone arrangements as well, scattered across thousands of miles of empty terrain. In Mauritania, in Mali, in the deep parts of Algeria, travelers and pilots have reported strange circles, long lines, and tomb-like piles called tumuli. Some are clearly graves, raised in honor of someone long forgotten. Others have no clear purpose at all. They sit in places where almost no one lives now, where the wind does most of the talking. What makes these stones so puzzling is the effort involved. Moving heavy rock across a flat, hot land is hard work. People did not do it by accident. They had a reason. They had a vision in their minds of how the stones should sit, and they followed that vision until the work was done. And then, for reasons we cannot fully trace, that knowledge slipped away. One quiet possibility is that the meaning of the stones did not vanish all at once. As the green Sahara dried out, the people who built these places moved away. Season by season, generation by generation, they carried their knowledge with them into the Nile Valley, into the highlands of the south, into the long memory of oral tradition. Pieces of that knowledge may still live in songs and stories we have not yet connected back to the stones, or they may be gone for good, dissolved by time the way the old lakes dissolved into dust. For now, the circles wait. The sun rises behind them and sets in front of them, just as it did when they were new. The wind smooths their edges by tiny amounts each century. Somewhere in their careful spacing, a meaning may still be hiding, patient and quiet, waiting for someone to read it again. Beneath the dry skin of the Sahara, in places where rain has not fallen in living memory, there is water. Not a little water. Vast, quiet pools of it, held in the rock like breath held in the chest. The largest of these hidden reserves is called the Nubian Sandstone Aquifer. It rests beneath parts of Egypt, Libya, Sudan, and Chad, and it is one of the biggest stores of fresh groundwater on Earth. The strange thing is the age of this water. Much of it fell as rain thousands of years ago, when the Sahara was green and rivers ran across its plains. The drops that soaked into the soil back then then slowly worked their way down through the layers of sandstone. There they have waited in the dark ever since. When a modern well brings some of it to the surface, the water that pours into the bucket is older than most of human civilization. Scientists call this kind of water fossil water. It is water that no longer refills because the climate that made it is gone. Once it is pumped out, it does not come back, at least not on any timescale that matters to a human life. So a small farmer in the western desert, watering a patch of melons, may be drinking from a rain that fell when mammoths still walked in cold parts of the world. How much of it is down there exactly is still an open question. Estimates run into the tens of thousands of cubic kilometers, but no one has truly mapped the whole pool. The rock layers twist and pinch in ways that satellites cannot fully see. Drillers in different countries report different depths, different pressures, different tastes. One well comes up sweet. Another comes up faintly salty. The aquifer is not a single lake. It is more like a sponge the size of a small sea, with hidden chambers and slow currents that no one fully understands. Above these reserves, on the surface, you can sometimes find small clues. A ring of palm trees in the middle of nothing. A patch of grass where no grass should be. A faint dampness in a hollow between dunes after a cool night. These signs hint at places where the water table presses up close to the sand. The old caravan guides knew many of them. They could read the desert the way a sailor reads the sea, and they passed the knowledge down in songs and short, careful sentences. In some valleys, the hidden water seeps to the surface on its own, forming small springs. The Siwa Oasis in western Egypt is one of these places. Date palms grow there in their thousands, fed by springs that bubble up from below. Salt crusts the edges of the pools in delicate white lace. The water in some of these springs is warm, heated by its long journey through deep rock. In others, it is startlingly cool. There are also caves down there, carved by water that worked through limestone over countless ages. A few have been mapped, many have not. Cavers who have descended into these hollow spaces describe rooms with still pools at the bottom. The water so clear it almost vanishes against the pale stone. tiny pale shrimp drift in some of these pools. How they got there, and how long their ancestors have been isolated in the dark, remains a quiet puzzle. One theory is that they are leftovers from the green periods, sealed in when the surface dried. Another idea is that thin underground channels still connect distant pools, allowing slow movement that we cannot see. The evidence is incomplete. The chemistry of the deep water is its own small wonder. Different layers carry different minerals, picked up from the rocks they passed through. Iron in some places tints the water a faint rust color when it meets the air. Elsewhere, dissolved calcium leaves slow rings on the inside of clay jars. Each well, in a sense, has its own personality. Whether these aquifers will outlast the present century is uncertain. Modern pumps move much more water than the old hand-dug wells ever could. New farms in the desert draw on the fossil pools to grow wheat and fruit. Some hydrologists worry that we are quietly draining a resource that took tens of thousands of years to build. Others believe the reserves are large enough to last for many generations if used carefully. For tonight, it is enough to picture it. A still, dark sheet of water far below the dunes, holding a memory of a wetter world. Old rain, patient in the stone, waiting in the quiet under all that sand. In a remote stretch of the western desert of Egypt, the sand holds a quiet puzzle. Scattered across a wide plain, between rolling dunes the color of pale honey, lie small pieces of yellow-green glass. Some are the size of a thumbnail. Some are larger than a fist. They shine softly in the sunlight, almost the color of olive oil held up to a candle. The local Bedouin people had known about them for a very long time. They picked them up from the sand, admired their strange beauty, and sometimes shaped them into tools. The wider world did not learn about this glass until the 1930s. A British surveyor named Patrick Clayton was mapping the remote desert near the border of Egypt and Libya. He drove slowly across a stony plain, listening to the soft crunch of his tires on the sand. He noticed the glass glinting at his feet. He picked up a piece, turned it in his fingers, and realized he was holding something that should not be there. Glass does not form on its own in a desert. Glass needs heat, a great deal of heat. Clayton collected samples and brought them back. Scientists studied the pieces with growing wonder. The glass was nearly pure silica, the same material that makes window glass, but it had formed naturally. Tests showed it was about 29 million years old. Somehow, long before the first humans walked the earth, something had heated the sand of this remote region to a temperature hot enough to melt it into glass. And then that glass had sat in the desert, scattered over a wide area, waiting to be found. The mystery deepened when researchers learned just how hot the event must have been. To melt silica into the kind of glass found in the desert, the temperature must reach well over 1,500 degrees. Nothing in ordinary weather can do this. Not lightning, which makes only thin, narrow tubes of glass. Not a wildfire, which is far too cool. Something extraordinary had happened in this place long ago. For decades, researchers have offered competing ideas. One theory is that a meteorite struck the desert, slamming into the sand with enough force to melt it instantly. Supporters of this idea point to traces of certain minerals inside the glass that often appear at known impact sites. But there is a problem. No clear crater has ever been found. The desert here is flat and ancient, and if a meteorite struck, the crater should still be visible, at least in some form. So far, the ground keeps it secret. Another theory suggests that the glass formed not from a direct strike, but from an airburst. In this idea, a large object from space exploded high in the sky above the desert. The blast of heat from the explosion would have washed down over the sand like a great invisible oven, melting the surface without leaving a crater. Some researchers find this idea convincing. Others remain unsure. The evidence is incomplete, and the debate is still alive. A third possibility is that the glass came from a combination of events, or from a process not yet understood. Tiny crystals inside some of the pieces have hinted at very high pressures, the kind seen in impacts. Yet, the spread of the glass across the desert is wider than most impact debris fields. The question of how it formed remains genuinely open. The story of this glass took a strange turn when archaeologists studied a famous artifact from the tomb of a young Egyptian king who ruled more than 3,000 years ago. Among his many treasures was a beautiful pectoral ornament worn across the chest. At its center sat a carved scarab beetle. The scarab was pale yellow-green, smooth and translucent. When researchers tested it, they found that the scarab was carved from desert glass. Somehow, ancient Egyptians had found this glass in the remote desert, carried it hundreds of miles, and shaped it into a sacred object for a king. How they found it, how they understood it, and what they believed about its origin, no one knows. The records do not say. The glass simply appears in the tomb, gleaming softly, holding its silence. So the desert keeps two mysteries in one. The first is how the glass formed deep in prehistory, when some great heat passed over the sand. The second is how humans, long before they had any way to study the stars or measure the heavens, recognized the strangeness of these little stones and treasured them. The pieces still lie out there tonight, scattered across the quiet plain, catching the moonlight as they have for millions of years, waiting patiently for someone to finally explain them. In a place where almost nothing seems alive, the ground itself remembers footsteps. Across parts of the Sahara, hidden in layers of stone that were once soft mud, scientists have found the prints of creatures that walked here long ago. Some of these prints belong to animals you would never expect to find in a desert. Hippos, crocodiles, elephants, even small barefoot humans walking side by side, pressed into the silt of a lake that no longer exists. The stone holds these tracks like a quiet photograph. A heel here, a toe there, a child's print beside an adult's, as if the two were walking together one warm afternoon thousands of years ago. The mud they stepped in slowly dried, then hardened, then turned to rock. Wind and sand eventually wore the rock back down to the surface. And now, after all this time, the prints sit in the open air again, waiting for someone to notice. What makes these footprints so strange is not just that they exist. It is what they prove. They prove that water was here. They prove that families lived along these vanished shores. They prove that the world before the desert was a busy, breathing place full of footsteps and splashes and bird calls. The stone is a kind of frozen moment, a single second from a wetter world preserved by accident. In southern Libya, in a place called the Mesek Plateau, researchers have mapped trackways of giant animals, elephants the size of houses, long-legged antelope, wild cattle that no longer roam this part of the world. In other regions, near old lake beds in Chad and Niger, the prints are smaller and more delicate. Tiny shorebirds, wading creatures with thin toes, lizards that left curling tail drags behind them. Each set of marks tells a quiet story, but the full story is far from complete. One mystery that researchers still puzzle over is how many of these footprint sites remain hidden. The Sahara is enormous. Most of it has never been walked by a scientist. New trackways turn up every few years, sometimes by chance. When a passing traveler notices an odd pattern in the rock, some experts believe the desert may hold thousands of undiscovered sites. Others think the harsh winds have already erased most of what was once there. The truth likely sits somewhere between those two ideas, and no one yet knows where. There is another strange detail in these ancient prints. In several spots, human footprints appear right beside the tracks of dangerous animals. A person walking near a crocodile path, a child's print not far from the heavy tread of a hippo. This tells us something gentle and surprising. People lived close to these creatures. They shared the same shorelines, the same drinking places, the same soft mud at the water's edge. How they managed this day after day is something we can only guess at. One theory is that the lakes were so rich with food and space that conflict was rare. Another idea is that early people knew the rhythms of these animals far better than we do today, and simply stayed out of their way. The age of the prints adds to the wonder. Some Saharan trackways are only a few thousand years old, from the last green period. Others stretch back much further, into times when the climate was different in ways we still struggle to picture. A single cliff face can hold prints from many different eras, stacked in layers like pages in a slow, patient book. Reading those pages is difficult. The mud does not always preserve the date along with the shape. troubles scientists most is how fragile these records are. A footprint that survived for 10,000 years can be lost in a single strong storm. Wind-blown sand can polish a print smooth in just a few seasons. Rain, when it does fall, can wash whole panels away. Every site that is found is also, in a sense, beginning to disappear. There is a quiet race in this work, though no one runs it loudly. Researchers map what they can, photograph what they can, and accept that much will be gone before anyone sees it. So, the desert holds its small, frozen moments, scattered across thousands of miles of stone. A heel, a toe, a child beside an adult, a bird beside a lizard. Each one a tiny window into a wetter, louder, livelier Sahara. Each one part of a larger question that has not yet been answered. How crowded was this place once? How many lives passed across this ground? How much of that old world is still waiting just beneath the sand for the wind to uncover it again? At the southern edge of the Great Desert, a lake is slowly disappearing. Its name is Lake Chad, and it once spread across an enormous stretch of land where 4 countries now meet. In old maps and old memories, it was vast. In satellite photos taken across the last 60 years, it has shrunk to a small fraction of what it once was. The water has pulled back like a tide that forgot to return, leaving cracked beds, salt flats, and quiet reeds where fish used to swim. To understand this vanishing, you have to look far beyond the lake itself. Lake Chad is fed by rivers that begin in the highlands to the south, where rain falls in heavy seasons. Those rains depend on a band of weather that drifts north and south across Africa each year. That band, in turn, is steered by the warmth of distant oceans, the tilt of the planet, and the slow breathing of the atmosphere itself. When the band shifts even slightly, the rivers swell or shrink. The lake feels every small change like a drum feels a fingertip. This is the strange thing about a desert and a lake. They seem like opposites, but they are part of the same quiet machine. The Sahara to the north pulls dry air down across the land. The forests to the south push wet air up into the sky. Between them lies a thin green belt called the Sahel, where the desert and the wet world meet and argue. Lake Chad sits in the middle of that argument. When the desert wins, the lake retreats. When the rains win, the lake spreads. Researchers still debate how much of the recent shrinking comes from a changing climate and how much comes from human use of the water. Farms have grown along the rivers that feed the lake. Canals draw water away for crops and herds. Some studies suggest that this drying off explains most of the loss. Other studies point to long droughts in the surrounding region and a shifting pattern of rains that may have little to do with people. The truth is probably a braid of both, but the exact weight of each thread remains an open question. The lake also connects to something even older. Beneath its bed lies the memory of a far greater body of water, sometimes called Megachad. Thousands of years ago, during one of the green Sahara periods, this ancient lake was one of the largest on Earth. It stretched across an area bigger than many seas. Fish swam through waters that now lie under dunes. Shorelines from that lost lake can still be traced in the sand, faint terraces marking where waves once lapped. The current Lake Chad is a small surviving pool of that older world. So when the lake shrinks today, it stirs a deeper question. Is this the slow end of a long fading, the final drying of something that has been disappearing for 10,000 years? Or is it a shorter swing, a low point in a cycle that will rise again when the rains return in greater force? Some climate models suggest the Sahel could grow wetter in the coming decades. Others suggest the opposite. The lake sits between these forecasts, waiting. The dust of the Sahara plays a part in this symphony too. Storms lift fine particles from the desert floor and carry them south on the wind. Some of that dust falls into Lake Chad and its rivers, adding minerals to the water. Some travels further still, feeding soils and forests far away. The desert and the lake and the rainforest are all whispering to each other across thousands of miles. Pull one thread and the others tremble. Birds know this conversation well. Each year, millions of them fly between Europe and Africa, and many pause at Lake Chad to drink and rest. The wetlands here are a stepping stone in a great migration. When the lake shrinks, the birds must travel further between safe waters. The desert above feels their absence. The forests below feel it too. A small change in one place ripples out into many. What this lake will look like in 100 years, no one truly knows. It may continue to shrink until it becomes a chain of small pools. It may swell again as the green Sahara stirs in its long sleep. The forces that shape it are too tangled to predict with certainty. Climate, water use, dust, wind, ocean, and human hand are all writing on the same page at once. For now, the lake holds steady at a quiet, smaller size, reflecting a sky that has not yet decided what it wants to become. The wind is the great sculptor of the Sahara. It works slowly, patiently, with no hands and no eyes. It lifts single grains of sand and sets them down again, a few inches further on, 1,000 times a day. Over centuries, those tiny movements build mountains of sand. Over millennia, they grind whole hills to powder. The desert you would see today is not the desert that stood there 1,000 years ago, and it will not be the desert that stands there 1,000 years from now. Most of the work is done by grains too small to see clearly. A breeze moves them in a low, hopping dance just above the ground. Geologists call this saltation, a fancy word for the small bounces sand grains make as the wind pushes them. Each grain rises, travels a short arc, and lands. When it lands, it kicks other grains loose. Multiplied across an entire desert, this gentle bouncing reshapes the whole surface, one tiny leap at a time. The largest dunes can stretch for hundreds of miles. Some rise as high as small mountains, towering more than 1,000 feet above the floor of the desert. These giants are called Dra, an old Arabic word for the longest sand ridges. They drift very slowly across the land, sometimes only a few feet a year, yet given enough time, they swallow oases, bury roads, and creep over the foundations of forgotten villages. A traveler returning to a familiar place after 50 years might find the well gone, the palms gone, the stones gone, replaced by a soft, golden hill. The wind also erases. Where it cannot bury, it scours. In the great rocky basins of the central Sahara, the wind has carved strange shapes called yardongs, long, low ridges look like beached ships pointing into the breeze. They form when steady winds, loaded with sand, scrape softer rock away and leave the harder rock standing. Some yardongs are the size of houses. Some are the size of city blocks. Each one is a record of how the wind has been blowing in roughly the same direction for thousands of years. How long these patterns last is itself an open question. Researchers studying old satellite images and ground surveys have noticed that dune fields can shift their orientation when the dominant winds change. There are signs in the Sahara of older dune patterns lying beneath the modern ones, pointing in different directions. They suggest that the wind itself has changed course in the past. What caused those shifts, and whether something similar is happening slowly right now, remains uncertain. The desert is changing in other ways too. Along its southern edge, in the region called the Sahel, the boundary between sand and grassland has moved back and forth across the decades. In some years, the desert seems to push south. In other years, the grasses creep north again. One idea is that the Sahara is slowly expanding as the climate warms. Another idea is that the boundary simply pulses, breathing in and out with the rains, and that the long-term trend is harder to read than it looks. Both views have evidence on their side. Neither has won the argument. Even the great Sahara of today is young by the measure of deep time. The green periods of the past, when lakes and rivers covered the land, ended only a few thousand years ago. That is a blink. The wind that now smooths the dunes is, in geological terms, still arranging the furniture in a room that was recently rearranged. Some of the dunes you would see if you walked the Sahara tonight may have formed within the last 2,000 or 3,000 years. Others may be older, built and rebuilt many times from the same restless grains. The grains themselves carry their own quiet history. Many were once part of ancient mountains, ground down by rivers that no longer flow. Some came from volcanoes whose craters have long since cooled and crumbled. Each grain has been lifted, dropped, buried, and lifted again, perhaps thousands of times. The desert is, in a sense, a vast, slow river of stone, flowing not downhill, but sideways, carried by the air. What no one can say with certainty is what the Sahara will look like in another 10,000 years. The wind may keep building the dunes higher. The rains may return and soften them into soil. The boundary may push south, or it may retreat. The grains keep moving, the ridges keep shifting, and the slow erasing and rewriting goes on, night after night, year after year, far from any eye that watches. The light in the Sahara is unlike the light anywhere else on Earth. At dawn, the sand glows soft pink, the color of the inside of a shell. By midday, the air shimmers white, and the horizon melts into a trembling line. By evening, the dunes turn the color of warm honey, then deep amber, then a quiet rust. And in this light, in this place that seems too harsh for life, small living things move. They move slowly. They move at night, but they are there. The first one to consider is the silver ant. It runs across sand hot enough to cook an egg. Its body is covered in tiny hairs that look almost mirror bright in the sun. Some scientists believe these hairs reflect light away from the ant, keeping it cool. Others think the hairs also release heat from the body in a different way, like a kind of invisible glow given off by warm things. The full picture is still being studied. What we do know is that the ant comes out in the hottest part of the day, when even snakes hide, and it sprints across the sand on long, thin legs, as if dancing on a hot stove. Then there is the addax, a pale antelope with twisted horns. Its coat turns nearly white in summer, bouncing the sunlight away from its skin. It can go for weeks, maybe months, without drinking. It pulls water from the dry grasses it eats, and from the cool dew that gathers in the early morning. How exactly its body holds on to every drop is not fully understood. The addax is now very rare in the wild. The quiet question of how it survived for so long in a place with almost no water remains only partly answered. Beneath the sand lives the sandfish, which is not a fish at all but a small lizard. It swims through the dunes the way a real fish swims through water. It dives in and disappears. Its smooth scales reduce friction, letting it glide between grains. Some researchers wonder if there is something special about the surface of those scales at a very tiny level, something that helps the lizard move without wearing down. Others think the shape of its body alone explains the trick. The debate continues in quiet laboratories far from the desert itself. At night, the light changes again. The stars come out so bright they cast faint shadows on the sand. Scorpions emerge, and here the desert offers one of its strangest small wonders. Under certain kinds of blue light, a scorpion's shell glows a soft, ghostly green. Scientists are still not sure why. One idea is that the glow helps the scorpion sense moonlight, telling it when to hide. Another idea is that it warns other creatures away. A third possibility is that it serves no purpose at all and is simply a side effect of the chemicals in the shell. No single theory has won. The fennec fox, with ears almost as large as its face, listens for insects under the sand. Its huge ears release heat, helping it stay cool. Its pale fur catches the moonlight and turns it almost silver. The fox is small enough to fit in a basket, yet it lives in a place that swallows whole caravans. How its tiny body holds on to water remains a question that biologists are still untangling. Even plants here play with light in strange ways. The Saharan cypress, of which only a few hundred trees remain in the highlands of Algeria, has needle-like leaves coated in a waxy film. The film reflects sunlight and slows down water loss. Some of these trees are believed to be more than 2,000 years old. They have stood through droughts that wiped out cities. How they continue to draw water from a land that seems to have none is not fully known. One theory is that their roots reach far down to hidden pockets of ancient water. Another is that they catch fog from rare cool nights. Both ideas may be partly right. What ties all these creatures together is a quiet refusal. They refuse the idea that the desert is empty. They refuse the idea that life needs softness to continue. In the long light of evening, when the dunes glow and the shadows stretch like ribbons, the desert is full of small, patient bodies waiting for the cool. The question of how exactly they manage the precise tricks of their cells and scales and hairs is still being slowly uncovered. The Sahara keeps its small wonders in plain sight, and yet only partly explained. softly in the long, golden light. The Sahara is often called silent. Stand in the middle of the great sand sea at midday, and the silence feels almost solid, as if the air itself has thickened into something you could press your hand against. But the desert is not truly quiet. It hums its sighs. It pulses in slow rhythms that scientists are only beginning to listen for. And among the strangest of these rhythms is something researchers sometimes call the green pulse, a slow heartbeat of moisture and life that seems to move through the sand on timescales far longer than a human breath. The idea begins with satellites. When instruments in orbit measure the faint signals of plant life across the Sahara, they sometimes catch tiny flickers of green where no green should be. A patch of grass appears for a single season after a freak rain. A blush of color spreads across a dry valley, then fades. From orbit, these flickers look almost like pulses on a vast, slow monitor. Some researchers wonder if the desert is breathing in a way we have not yet mapped, drawing in moisture, releasing it, drawing it in again, across decades and centuries. If you could turn this rhythm into sound, it might be the lowest note imaginable. A pulse so slow that a single beat would take a human lifetime. The wind hissing across dunes would be the high frequencies. The rare crack of thunder in a dry storm would be the percussion. And underneath, almost beyond hearing, the long swell of the green pulse itself, rising and falling on the rhythm of climate. Whether this pulse is real or simply a pattern our brains find in scattered data remains an open question. One view holds that the Sahara is locked in a slow oscillation, subtle shifts in Earth's tilt, in ocean temperatures, in the angle of summer sunlight over North Africa, may push the desert toward green and back toward sand in long cycles. Under this idea, the flickers we see from orbit are the small early notes of a much larger song. Perhaps the first whispers of a wetter Sahara still thousands of years away. A competing view is more cautious. Some researchers argue that these green flickers are random, driven by chaotic weather rather than any deep rhythm. A storm wanders south. A pocket of moisture settles in the wrong place at the right time. Seeds that have waited in the sand for years suddenly sprout, then die back. There is no pulse, only noise. The desert is not breathing. It is simply old and patient, and occasionally surprised by rain. Sound itself behaves strangely in the Sahara, which makes the search for any pulse harder. Travelers have long reported a phenomenon called singing sand. In certain dunes, when the sand slides down a steep face, it produces a deep humming tone that can carry for miles. The note is low, almost like a distant pipe organ, and it can last for many minutes. Researchers have measured these sounds carefully. They know the grains must be a certain size, dry to a certain degree, and moving at a certain speed. But why some dunes sing and others stay silent is still not fully understood. There is also the quiet groan of the desert at dawn. As the sun rises and the cold night air begins to warm, the sand expands. Tiny grains shift against each other. Rocks crack. In some places, this creates a low, almost subliminal rumble that microphones can catch, but human ears barely register. It is the sound of a vast surface stretching awake. Whether such sounds connect in any way to the longer green pulse, to the slow breathing of moisture across millennia, is not known. Some scientists have begun to listen to the underground too. Buried aquifers, ancient pockets of water hidden far below the sand, sometimes shift and settle. Seismic instruments occasionally pick up faint signals that may come from these deep reservoirs, or may come from something else entirely. The data is sparse. The interpretations are open. What we are left with is a desert that seems almost too quiet, and yet hums with possibilities we cannot quite hear. The green pulse may be real, a slow note in Earth's long song. It may be a trick of pattern found by minds that crave meaning. It may be something stranger still, a process not yet named. For now, the satellites watch. The sand sings on certain afternoons, and the question rests where most Saharan questions rest. Somewhere between the dunes and the deep time below them, waiting for someone patient enough to listen all the way through. There is a quiet kind of mathematics that lives in the desert. It does not shout from chalkboards or fill thick books with symbols. It hides in the shapes the sand makes, in the curves of dry valleys, in the spacing of stones. And in recent decades, satellites high above the Sahara have begun to read this hidden math. They see things the human eye on the ground can never see. They trace patterns that whisper of a wetter world. The most striking of these patterns are the ghost rivers. From orbit, instruments that can see through thin layers of sand have mapped long, branching channels under the dunes. These channels twist and split and rejoin in the same way living rivers do today. Some run for hundreds of kilometers beneath the surface, buried under wind-blown sand. They are not water now. They are only the memory of water pressed into the rock and the gravel below. The math of these ghost rivers is beautiful in its own quiet way. Real rivers, the kind that still flow on Earth, follow simple rules as they branch. A larger river splits into smaller streams in predictable ratios. The angles where streams meet tend to cluster around certain values. The lengths of the branches relate to one another in patterns that repeat at every scale. A small creek looks, in its shape, very much like the giant river it feeds. The buried channels of the Sahara follow these same rules. When researchers measure them from satellite data, the numbers match the numbers of living rivers in wetter parts of the world. The branching ratios, the angles, the way the smaller veins feed into the larger ones. This is one of the strongest pieces of evidence that real rivers once flowed here, carrying real water across a land that is now mostly stone and sand. One theory holds that these ghost rivers were active during the green Sahara periods, the long stretches when monsoon rains crept far north. Water collected in highlands, ran across plains, gathered into great channels, and emptied into lakes and seas. When the rains pulled back, the rivers slowly dried, and the wind covered them. Another theory suggests that some of the channels are much older still, carved during even earlier wet phases, perhaps tens of millions of years ago. The two ideas are not in conflict, but the timeline remains open. The sand has not given up its dates easily. The satellites see other patterns too. They measure tiny shifts in gravity from orbit. Where there is more mass beneath the surface, gravity pulls a little stronger. Where there is less, it pulls a little weaker. Across the Sahara, these gravity maps reveal vast underground basins of water, held in porous rock far below the dunes. The shapes of these basins follow the shapes of the ancient rivers above them. The water that once ran on the surface now sleeps in the stone. There is a kind of elegance in how all of this connects. The river branches obey simple geometric ratios. Those ratios are the same ones found in the veins of a leaf, in the branching of lightning, in the tributaries of the Amazon. The same math, repeating at every scale, in every climate, on every continent. The desert is not separate from the living world. It uses the same rules. It just runs them more slowly and in deeper time. What no one can yet calculate with certainty is how complete the map will become. Every new satellite mission, every new pass with a sharper instrument, reveals channels that were missed before. Some researchers estimate that most of the Sahara's ancient drainage network is still hidden. Others think the major arteries are now well traced, and only the small veins remain to be found. The total length of buried river, if you could lift the sand away, may run to many thousands of kilometers. The precise number is unknown. There is a quieter question folded inside the math. If the rivers branched this way, then they once carried water in volumes large enough to sustain those patterns. Large enough, perhaps, to feed lakes the size of small seas. Large enough to support fish and the creatures that ate the fish and the people who fished from the banks. The geometry, in its calm and abstract beauty, points back to a living world, a world of currents and reeds, and the soft sound of moving water in a place that today knows only wind. The numbers do not say when the water will return. They do not promise anything. They only show, in clean ratios and gentle curves, that this land has held rivers before. The map of the ghosts is still being drawn. And somewhere beneath the dunes tonight, the old channels lie waiting, patient, holding the shape of a wetter Sahara in the silence of the dark stone. In certain parts of the Sahara, when the wind has stripped the sand low and the cliffs stand bare in the afternoon light, you can see openings carved into the rock, square mouths, round mouths, doorways cut by patient hands long ago. Some sit high above the desert floor, in cliffs that now face nothing but heat and silence. They are tombs, or shrines, or storerooms. The truth depends on which scholar you ask. These rock-cut chambers turn up in many corners of the great desert. Some lie in the cliffs of southern Libya. Others appear in the highlands of Algeria, in the dry valleys of Egypt, in the broken hills near the Nile. They were carved when the climate was kinder, when rivers still ran nearby, and grass still grew at the foot of the stone. The people who made them are mostly gone. Their names are gone too. What strikes the eye first is the loneliness of these places. A tomb cut into a cliff is a serious piece of work. It takes tools, time, and many strong hands. It takes a community that believes the dead deserve a careful house. Yet today many of these chambers open onto empty pans of sand. No village, no water, no path, just wind and heat and the long view of nothing. This is what we mean when we speak of fragile balance. The world that built these tombs no longer exists. A small shift in rainfall, a small drift of the seasonal winds, and the green vanished. The herds vanished. The fields vanished. The people walked away, taking their songs and their language and their gods with them. The cliffs stayed. The doorways stayed. But the soft web of life that gave them meaning thinned out and was gone within a few generations. It is hard to grasp how thin that web really is. The Sahara is green or dry, depending on a wobble in Earth's tilt of just a few degrees. That wobble changes how much summer sunlight falls on the northern half of the planet. More sunlight means stronger monsoons that push deeper into Africa. Less sunlight means the rains pull back toward the coast. The difference between a grassland and a desert can rest on a number most of us would barely notice. The same is true of the air above us. The atmosphere that holds the Sahara's heat in by day and lets it escape by night is only a thin shell around the planet. If you could drive straight up from the dunes at highway speed, you would leave most of it behind in under an hour. Inside that shell, water moves in great looping currents. Dust rises and falls. Carbon and oxygen trade places inside leaves and lungs. Change any one of these flows a little, and deserts grow or shrink. Even the distance to the sun matters. Earth's path around it is not a perfect circle. It stretches and relaxes over long cycles of tens of thousands of years. When the path is more stretched, the seasons grow sharper. When it is rounder, they soften. Some researchers think these slow stretches help drive the green Sahara periods. Others think the tilt of the axis matters more. The full recipe is still being worked out. What the tombs in the cliffs remind us is that human life rides on top of all this. The people who carved those chambers were not foolish. They built where the land could feed them. They chose cliffs near water, near pasture, near trade. The land changed under their feet, slowly enough that no single year felt like disaster, fast enough that within a few centuries, the place was unlivable. They did not see the wobble. They only saw the wells drop and the grass thin. Stand in front of one of those empty doorways now, and the question grows quiet and large. How thin is the layer of comfort we live inside? How many small numbers had to line up just so for the wheat to grow, for the river to flow, for the city to rise? One theory holds that the Sahara's flips between green and dry are gentle, taking many lifetimes. Another holds that they can tip in a single generation. Once a threshold is crossed, the evidence sits on both sides. The tombs do not answer. They only stand there in the heat, mouths open to a wind that no longer carries the smell of rain. They were carved for a world that seemed steady to the people inside it. They sit now in a world that proves how little steadiness any of us is promised. The cliffs keep their secrets. The desert keeps watching, and the slow numbers keep turning. In the heart of the Sahara, far from any coast, two great mountain ranges rise out of the sand. The Taibesti, in what is now northern Chad, lifts black volcanic peaks more than 3,000 meters into the dry sky. The Hagar, further west in southern Algeria, spreads its weathered stone fingers across a quieter, lower plateau. Together, they form the silent heart of the desert. And in many ways, they remain among the least understood places on Earth. Few outsiders have walked their slopes. Roads are scarce. Conflict, distance, and harsh weather have kept scientists away for decades at a time. Satellites can map the shape of the peaks from above, but the close study, the slow, patient walking with a notebook, has barely begun. Whole valleys in the Typesty have been visited by only a handful of geologists in the last 100 years. What makes these mountains so puzzling is that they should not look the way they do. The Typesty holds volcanoes that have erupted within the last few thousand years. Hot springs still bubble from cracks in the rock. Steam vents hiss in places where the desert sun beats down hardest. Yet the region sits far from any obvious plate boundary. The volcanic forces that built the Andes or the Cascades have clear sources. The forces beneath the Typesty do not. One theory points to a hot spot, a plume of warm rock rising slowly from deep within the mantle. Such plumes are thought to feed places like Hawaii and Iceland. Some researchers wonder if a quiet, long-lived plume sits beneath Central Africa, lifting the crust into these strange high domes. A competing idea suggests the cause lies closer to the surface, in old fractures left behind when Africa pulled away from South America long ago. These cracks may still leak heat in slow, irregular pulses. Both ideas fit some of the evidence. Neither explains all of it. The Hogger adds its own questions. Its rocks are far older than those of the Typesty, some among the oldest exposed stones in Africa. Yet volcanic cones, young and sharp-edged, sit scattered across its plateau like dark hats placed on ancient shoulders. How a region of such old crust came to host such young volcanoes is a puzzle scientists have argued about for generations. The answers may lie kilometers below, in structures no drill has yet reached. Then there are the climate records hidden in the mountain lakes. High in the Typesty, a few small crater lakes still hold water year-round. Their muds preserve layers of pollen, ash, and tiny shells stretching back thousands of years. Each layer is a page in a slow book about how the Sahara once was. But these lakes are remote and difficult to sample. Only a few short cores have been taken. The full book has barely been opened. The mountains also hold rock art, painted and carved into shelters at high altitudes. Some images show cattle, Others show people in tall headdresses. Others show animals no one can quite identify. The dates of these artworks remain uncertain. Some may be 6,000 years old. Some may be older. Who climbed so high to make them, and why they chose these silent peaks rather than easier lowland walls is a question no one has fully answered. One idea is that the high places were sacred, set apart for ceremony. Another is simply that water lingered longer at altitude, drawing herders upward as the lowlands dried. Both could be true. Neither has been proven. Even the wildlife of these mountains hides surprises. A small population of West African crocodiles was discovered in remote Typesty waterholes only in the last few decades. They are leftovers from the wetter Sahara, somehow surviving in pockets of shaded pools fed by hidden springs. How many such pockets remain scattered across the central desert? No one truly knows. New ones are still being found. The silence of these mountains is not emptiness. It is the silence of a library no one has fully read. Each unmapped valley, each unstudied lava flow, each unsampled lake bed holds pages that might shift the story of the Sahara. The desert's greatest mystery may not be hidden under the dunes at all. It may be standing in plain view, rising in dark peaks above the sand, waiting for someone to climb closer and listen. For now, the Typesty and the Hogger keep their patient counsel. The wind moves across their black slopes. Hot springs whisper in cracks. Old paintings watch from shelters no one visits. And somewhere beneath them all, slow forces of heat and stone continue their work, indifferent to whether we ever understand them. The mountains will wait. They have time. For thousands of years, before satellites mapped every dune, and before written records reached deep into the desert, the memory of the Sahara lived in the minds of people who walked across it. The nomads carried stories the way they carried water. Each tale was a small vessel of knowledge, passed from grandmother to grandchild around low fires under enormous skies. Some of those stories described places that no longer exist. Some described wells in the middle of nowhere that, when checked, were actually there. And some described a desert that was once green, Tuareg, the Berber peoples, the Taubu, the Sahrawi, each group holds a different braid of memory. Their songs and poems mention rivers that ran where there is now only sand. They speak of trees that grew where nothing grows today. Some researchers wonder whether these stories carry faint echoes of the green Sahara that ended only a few thousand years ago. Other researchers think these tales are more recent, shaped by smaller wet spells or by the human longing to imagine a softer world. The truth is probably somewhere in between, and we may never sort one strand from the other. What is clear is that the people of the desert have always paid close attention to small signs the rest of us miss. A certain shade of sky at dusk, a shift in the smell of the wind, the way the sand sounds underfoot at noon versus at dawn. This knowledge is a kind of science, gathered slowly, tested over generations. It tells a story about a desert that is not as still as it looks. The dunes breathe. The wells fill and empty in long, patient cycles. The grasses come and go with the rains. Now consider the future. In 1,000 years, the slow wobble of Earth's axis will keep nudging the planet toward a wetter African monsoon. In 10,000 years, if the patterns of the past hold, the Sahara may begin to green again. Lakes could reappear in basins that are now dry hollows. Grasses could spread north from the Sahel. Some scientists think this shift could be gradual, taking many human lifetimes. Others wonder if it could happen faster, in a sudden flip from desert to savanna. The way ice ages have sometimes ended in a few short centuries. The question stays open. And what of the much deeper future? In 1,000,000 years, the African plate will have crept a small but real distance to the northeast. The mountains of the central Sahara will be a little lower, worn down by wind. New ranges may have begun to rise elsewhere as the crust adjusts. In 10 million years, the Mediterranean itself may have narrowed as Africa presses slowly into Europe. The desert that we call the Sahara today will not be in quite the same place, and it may not be a desert at all. Go further still, and the picture grows stranger. In 100 million years, the continents will have rearranged themselves into shapes we would not recognize. The dust that once blew from the Bidele Depression to the Amazon may by then be blowing across an entirely different ocean to feed forests that do not yet exist. The bones of whales in the Egyptian sands will be deeper, or perhaps lifted into new hills by tectonic forces we cannot fully predict. The eye of the Sahara may have eroded into a softer ring, or been buried under younger rock, or exposed even more clearly to whatever eyes are looking down at it then. Across 1 billion years, the sun itself will grow slowly hotter. Long before it swells into its final form, the oceans of Earth may begin to thin, and the green cycles of the Sahara may end for good. Yet even in that distant time, the sand will keep moving. The wind will keep sculpting. Some quiet form of weather will keep shaping the surface of this rocky world. New patterns will appear that no nomad ever sang about, because no nomad will be there to see them. For now, the stories carried by the desert peoples remain one of our best windows into the recent past of the Sahara. They are imperfect, layered, and often poetic. Scholars debate how much of each tale is memory and how much is invention. The desert keeps its own counsel either way. It has been green before. It will likely be green again. And somewhere between the slow turn of the sky and the patient steps of a camel at dusk, the great question of when and how and what will come after remains gently, beautifully unanswered. Step back now. Step back from the dunes and the cliffs and the dry riverbeds. Step back from the painted caves and the buried bones and the silent mountains. Picture the Sahara from very high above, the way a quiet bird of the upper sky might see it. A great pale shape across the top of Africa. A sea of sand and stone, slowly breathing in and out across the long ages of the earth. From this height, the desert is small. It is only a thin skin on a round and living world. And that world is only a small blue stone turning in a much larger silence. The Sahara, with all its secrets, sits on the surface of something even more mysterious. A planet that itself is still mostly unknown to the creatures who live on it. The sand under those dunes is made of broken rock. The rock was once mountains. The mountains were once the floors of ancient seas. The shells in those seas were built by small, soft creatures who pulled minerals from the water. And those minerals, every grain of calcium, every atom of iron in the red Saharan dust, came from somewhere older still. They came from the cores of stars that lived and died long before the earth was born. The desert, in a quiet way, is made of starlight that cooled and settled and learned how to hold a shape. The same is true of the listener. The same atoms that drift across the Atlantic in Saharan dust also drift through human bones. The calcium in a person's spine, the iron in their blood, the carbon in every breath, all of it was forged in stars and scattered across space long ago. The desert and the body are cousins in this way, made of the same old material, shaped by the same slow forces. Both of them, in their own ways, still holding secrets they have not yet shared. This is part of why the Sahara feels the way it feels. It is not just empty. It is full of time. Every grain of sand has been somewhere. Every stone has watched something. The wind that moves the dunes tonight is the same wind, more or less, that moved the boats of forgotten traders. The sun that warms the rocks at dawn warmed the painters of Tassili and the swimmers in their cave murals, and the whales who once swam in shallow seas where the dunes now stand. And under all of that, beneath the bright skin of the desert, there is so much we have not yet seen. Buried rivers we have only begun to trace. Tombs we have not opened. Cities that may still wait under the slow drift of the sand. Lakes of fresh water sealed below stone. Footprints pressed into mud long before any of us were thought of. The Sahara is one of the largest unread libraries on Earth, and the pages are written in dust and bone and groundwater and stone. Some researchers believe the most important Saharan discoveries are still ahead. New satellites can see through sand in ways that were not possible before. New methods can date a footprint, a hearth, a piece of pottery with growing care. Others wonder whether the most important things will stay hidden. The desert is vast. Erosion is patient. Whole peoples may have lived and loved and vanished without leaving a single trace we can still find. The truth is likely both at once. Some secrets will surface. Others will sleep forever. And above all of this hangs the larger question. the one the desert has been asking quietly through every section of this long night. When will the green return? The Sahara has been green before, many times, in long, slow rhythms tied to the wobble of the earth itself. Some scientists suspect another green phase is coming, perhaps in 15,000 years, perhaps sooner if the climate shifts in unexpected ways. Others think human warming may delay or scramble the old pattern entirely. No one knows for certain. The desert keeps its own calendar, and it does not share. So the perspective at the very widest view is this: a small blue planet, a great pale desert on one side of it, a sky full of old starlight, and underneath the sand, a buried world that is partly ours and partly something stranger. The listener, made of the same atoms, breathing the same air, sharing the same long story, all of it moving very slowly toward something none of us will live to see, and yet something the earth has seen many times before. The Sahara is patient. It can afford to wait. And tonight, so can we. And so we come to the end of our long, slow walk across the Sahara. The dunes are quiet now. The wind has softened. The stars wheel slowly above a sleeping desert, and the sand cools beneath them, hour by hour, grain by grain. Think for a moment of all we have wandered past tonight. The strange round eye of stone in Mauritania, staring up at the sky from the floor of an ancient land. The bones of whales lying in dry yellow sand. The soft chalk of creatures that once swam where camels now walk. The painted swimmers on the cave walls of Tassili, their slow strokes preserved for thousands of years in dry red stone. The ghost rivers running deep below the surface, invisible to the eye, traced only by satellites that listen for water with patient electronic ears. We have listened for the lost city of Zerzura, the white oasis that travelers spoke of and no one has ever found. We have wondered at the silent stone circles of Nabta Playa, set in place by hands we will never meet. We have watched the dust of the Sahara lift into the wind and travel across the Atlantic, falling at last on the Amazon, feeding green leaves with the memory of an old green sea. So much of it remains unanswered. We do not know exactly when the Sahara will turn green again. We do not know how many cities still sleep beneath the dunes. We do not know who painted the swimmers, or who carried the salt along the old roads, or what stories the nomads have kept folded inside their songs. The desert holds its secrets gently, the way a hand holds water. It does not rush to tell us anything, and perhaps that is the kindest gift the Sahara gives. It reminds us that we live on a planet older and wider than our knowing, that below every flat horizon there are layers of forgotten worlds, that above every silent dune there are slow winds carrying news from places we will never visit, that the earth is patient. The earth is patient in a way we are still learning how to be. Picture the planet now from far away. A soft blue sphere turning slowly in the dark. The night side cool and dim. The day side bright with a thin shell of cloud. The Sahara, a pale gold smear across the north of Africa, calm and warm and slowly breathing. The oceans deep and dark, holding moonlight on their surface like a thin silver skin. The mountains quiet, the forests quiet, the cities small, bright sparks here and there along the coasts. Everything is held. Everything is turning at the same gentle speed it has turned for billions of years. The wind that moves a single grain of Saharan sand tonight is the same wind, in a sense, that moved sand here when the first green rivers ran. The light that touches your closed eyelids has traveled from a sun that has shone over every chapter of this desert, every green age, every dry age, every painted cave, every silent tomb. You are small. The desert is large. The planet is larger. And yet the planet is small too when you set it against the dark. And somehow that smallness feels safe rather than lonely. We are all here together. The dunes, the whales in their stone, the nomads moving by starlight, the dust on its long flight to the rainforest, the listener lying still in a warm bed. All of us riding the same slow turning world. Let the questions stay open. Let the desert keep what it wants to keep. Let the buried rivers run under sand for another 1,000 years if they choose. We may know more in our lifetime. We may not. The mystery is not a puzzle to be solved before morning. It is a quiet companion, a slow friend, something to wonder about on long, calm nights like this one. The wind across the dunes is soft now. The stars are clear and steady. The sand has gone cool, and the planet turns and turns and turns. Wherever you are tonight, you are held by something old and patient and beautiful. You are allowed to rest. You are allowed to let the questions stay questions a little longer. The Sahara has waited a very long time, and it does not need an answer tonight. Let your breathing slow. Let your shoulders soften. Let the long sleep of the desert become your sleep too. Subscribe for a brand new Earth topic every night. One tap, and something wonderful is waiting for you tomorrow. Sweet dreams.